This topic is about numeral systems, and then the daily language we talk about numbers. Basically, we are using something called decimal system, decimal number. Decimal number is the most common is because humans have 10 fingers. It's easier for us to use finger to describe some value by using different digits. That's why we just invent from 0 to 9. In total 10 symbols to represent the values. And then any number larger than 9, then we use multiple digits to represent it. For example, like 1, 2, 3, 4. Usually, if we don't write down this number, then we will assume default this one is a decimal number. That means our daily values. And in this number, there are in total 4 digits. Every digit represents different values. If we decompose this number, the first digit means 1000. The second digit 2 here means 200. The next digit means 30, and the last digit means 4. 1 here representing 1000, 2 here representing 200. So if you break down to find out the relation between the number here together with the base, that means 1 times of 1000. And then we have 2 times of 100, 3 times of 10, and then 4 times of 1. So it seems like you're paying some amounts. You need to prepare $1,000 notes, and then 2 times of $100 notes, 3 $10 notes, and 4 coins with $1 face value, something like that. So it's not difficult to decompose, and that means it is 1 times 10 power 3 plus 2 times 10 power 2, and then plus 3 times 10 power 1, and plus 4 times 10 power 0. That's how you decompose it by digit. And then when we go to another numerical system, it's exactly the same. So the next one we are talking about binary. Binary is just like the switch. That means the electric light, you can only control it switched off or switched on. So we have 2 symbols. Now we have only 0 and 1. But just now in decimal number, we can choose 0, 1, 2, until 9. We have 10 symbols to put in each digit. But now for each digit, that means each place, we can just choose 2 symbols. For example, if I want to describe 0, then in binary, maybe just 0. And then if 1, then this is 1. But how about if I want to further increase by 1 to get 2? Then we have only 0 and 1. That means I don't have enough fingers to describe it, right? So that's why we change 1 back to 0. But the next digit, we change from 0 to 1. So the next one is fine because we still have some space to change 0 to 1. So the next value is 1, 1. After that, we have to increase it by 1, but it's already used up all the symbols, so we change it back to 0. And then the next digit increased by 1, but again, we have to change it to 0. And then we use one more digit, 1. The next one is 1 here, and then this is 0, 1. Increased up by 1 again, so 1 will change to 0. And when I change it to 0, I need to change the next digit, increase by 1. So 110 representing 6. And then 0, we can still increase by 1 to get 1. Do not affect another digit. 1 will become another digit, which is 0. And it's affect the next digit, so it's become a train effect. 1 increased up by 1, we get 0, and we need even one more digit. So 1, 0, 0, 1. That's how we build up the binary system to use some switch just on or off to represent different values in our 10 fingers. But the operation is just the same as decimal. So for example, we have a binary number, which is 1001. Just now we already know that 1001 representing 9. But how can we write this one? First, it's about the power. The first digit representing 2 power 0, the second digit representing 2 power 1, third one representing 2 power 2, and the last one representing 2 power 3. To decompose it, 1 times of 2 power 3, and we have another 1 times of 2 power 0. So we have 1 times 2 power 3 plus 1 times 2 power of 0. For those 0 something, 0 times the value, the place value will become 0, so we just ignore it. Then we have 2 power 3 plus 1. That means 8 plus 1, we get back 9. The logic of hexadecimal are exactly the same. In decimal number, we have 10 symbols from 0 to 9. In binary, we have 2 symbols from 0 to 1. In hexadecimal, we need to use some 1 symbols to represent 10, 11, 12, something like that. So we borrow the English letter. 10 represented by A, 11 represented by B, C, D, E, F, like this. Be reminded that F representing 15 but not 16 because 16 we are using another digit already. It seems like we have 10 symbols in decimal number, but the largest value, the largest symbol is 9 but not 10. So when we decompose it, we use the same logic. The first digit here representing 16 power 0. This is 16 power 1 and the next one is 16 power 2. So that means we have A times of 16 power 2, we have 3 times of 16 power 1, and finally we have B times of 16 power of 0. When we decompose it, we want to change it to decimal system. So A, we translate it to 10. And then 3, we don't need to change. B, we translate it to 11. It will become 2560 and then plus 48 and then plus 11. So in hexadecimal, these 3 digits together, that representing 2619 in decimal system.